In the last class we did till question number 8. So now we can start question number 9. So till question number 8 it was from relations and functions. So now we can start the new chapter. So it is determinants. So before starting this determinants, we can see some of the properties from both matrices as well as determinants. So that I will write here. Properties. This is from matrices chapter. Properties. Suppose if we have A transpose the whole transpose. So either we can write like this A transpose, or we can write like this A dash here. So A transpose the whole transpose, it will be equal to A itself. Then K times A, Ka the whole transpose will be equal to K into A transpose. A plus B the whole transpose will be equal to A transpose plus B transpose. And here AB, this is product. AB the whole transpose will be equal to B transpose into A transpose. So now if it is symmetric, then A transpose will be equal to A itself. If it is skew symmetric, then A transpose will be equal to negative of A. Always A plus A transpose will be symmetric. This is always. Now if A plus A transpose is symmetric, after multiplying with some constant K, K times A plus A transpose is also symmetric. And the next thing here is A minus A transpose is always skew symmetric. And K times A minus A transpose is also skew symmetric. Suppose in case if we have to write a matrix A as sum of symmetric and skew symmetric, we can take that as some matrix P and plus Q. So this matrix P is symmetric and this matrix Q is skew symmetric. So if I write this matrix P as just A plus A transpose and matrix Q as A minus A transpose, LHS is not equal to RHS. Suppose if you simplify this, A transpose negative of A transpose, it will get cancelled. So A will be equal to 2A. So this is not possible. So only we have to divide by 2 here. This is for symmetric matrix. After multiplying with some constant K also, still it will be symmetric. So here also this is skew symmetric matrix after multiplying with some constant K. So it is also skew symmetric. So we have to write like this: A equal to, this P is nothing but half into A plus A transpose. So this will be symmetric. And this Q is half times A minus A transpose. So this will be skew symmetric. So now we will see what is inverse of a matrix. See here, always this theorem is valid. A into adjoint of A will be equal to adjoint of A into A equal to determinant of A into identity matrix. This I is identity matrix. Now suppose in real number, if I take 2 into what number is equal to multiplicative identity, which is 1. So here I have to take the reciprocal of this 1 by 2. And same thing here in matrix, this 1 is nothing but identity matrix. So we have to check A into some matrix B. If it is equal to identity matrix, then I can say this B is nothing but A inverse. This B is nothing but A inverse. So for that, what I can do here is, here identity matrix we have some determinant A into identity matrix we have, this part and this one I will equate. So I will get A into adjoint of A equal to determinant of A into I. So what I will do here is I will just divide by determinant of A both sides. I can able to divide by determinant of A if this determinant of A is not equal to 0. So which means it should be non-singular matrix. Non-singular matrix. So from here, this determinant of A and this determinant of A will get cancelled. I am getting some matrix A into 1 by determinant of A into adjoint of A equal to identity matrix. So which means matrix A into this matrix is equal to identity matrix, means this will be A inverse. So A inverse we got as 1 by determinant of A into adjoint of A. So we know how to find the adjoint. Adjoint is nothing but we have to find first minor, then we have to change some of the signs. So if minus 1 power I plus j, if I plus j is even, same sign will be there. If I plus j is odd, then we have to just change the sign. If it is 3 cross 3 matrix, this side we should not change the sign from the minor. For these 4 elements we have to change the sign. Next, after finding the cofactor, to find adjoint we have to take the transpose of cofactor. Now we will see some properties of inverse. Properties of inverse. A inverse, the whole inverse, will be equal to A itself. Ka the whole inverse will be equal to not K into A inverse. This is wrong. So it will be 1 by K into A inverse. So we should not confuse with this part. Ka the whole transpose is equal to K times A transpose. But here Ka the whole inverse is nothing but 1 by K into A inverse will be there. And A inverse the whole transpose will be equal to, first we can take transpose, then we can take A inverse also. So next thing, A plus B the whole inverse, it is same as taking inverse separately, A inverse plus B inverse, and AB the whole inverse, this is multiplication. After multiplying we are taking inverse. So this will be same as B inverse into A inverse. And the next thing, here is some determinants property I will write. Properties. Here determinant of identity matrix, it can be I2. I2 means order is 2 cross 2. I3 means order is 3 cross 3. So for I4 also if we have, so 4 cross 4. So any matrix, any identity matrix, the determinant of any identity matrix will be equal to 1. And determinant of A transpose will be equal to determinant of A itself. So if we have to find determinant of AB, this is same as finding determinant of A into determinant of B. And determinant of A inverse, if we have to find, this is 1 by determinant of A. Because A into A inverse equal to identity matrix. So which means I am taking determinant on both sides. Identity matrix determinant is 1. This I can use this property. So determinant of A into determinant of A inverse. So which is determinant of A inverse will be 1 by determinant of A. So this is what we have. And determinant of K times A will be equal to K power n into determinant of A, where n is the order. Determinant is only valid for square matrix, which means m will be equal to n here. And next thing, determinant of, suppose if we have adjoint of A, this will be determinant of A power n minus 1, here also where n is order. Suppose if you have determinant of minus A, this can be written as minus 1 into A. So this minus 1 is what? Scalar, which means we have to compare from this. So it will come like this, minus 1 the whole power n, n is the order, into determinant of A. So if a matrix is 2 cross 2, then determinant of minus a will be equal to minus 1 the whole square, so it will be equal to determinant of a itself. If a matrix is 3 cross 3, then determinant of minus a will be equal to minus determinant of a. It will be like this. If a matrix is 3 cross 3, so n value is 3. N is nothing but order. This n is 3 here, and here n is 2 here. So these are the some of the properties from matrices and determinants chapter. So now we can start solving this 9th question. So in this 9th question, we have a is given 1, 2, minus 2, and b inverse is given. We have to find ab the whole inverse. So ab the whole inverse, after using this property, so ab the whole inverse is what? B inverse into a inverse. So b inverse into a inverse. So b inverse is already given. So first we have to find the a inverse. So how to find the a inverse? I have written the formula. So it is 1 by determinant of a into adjoint of a. So we have to find minor cofactor, then transpose of cofactor is adjoint of a. So first we will find determinant of a from here. So 1 into, so after taking 1, we have to delete the row in which 1 is present and the column in which 1 is present. So determinant of 3, 0, minus 2, 1. So then we can expand along row 1 or row 2 or row 3 or column 1 or column 2 or column 3. So there are 6 possibilities to find determinant. For all, the answer will be same. So here alternate sign we have to change. So plus, minus, plus. If I am taking this element, so it should be plus. If I am taking this element, it should be minus. So here minus, plus, plus, minus, minus, plus. It should be like this. So only these 4 places we have to change the sign. If we are taking any element from these 4 places, we have to just change the sign. Plus means minus, minus means plus. So here minus 2 into. So after writing this, we have to delete the row in which this 2 is present and the column in which 2 is present. So which means this column, this row and this column we have to delete, and it will be minus 1, 0, 0, 1. So next thing here is minus 2. With the sign we have to take, because plus is here. With the sign, whatever sign we have to just write. So we have to delete the row in which minus 2 is present and the column in which minus 2 is present. So it will be minus 1, 3, 0, minus 2. So now we know how to find the determinant of 2 cross 2 matrix ABCD if we have. So just AD minus BC. So we have to just apply that. 1 into 3 minus 0, no need to write. Minus 2 into minus 1, then again 0, no need to write. So minus 2 into minus 1 into minus 2, it is just 2. So then again 0, no need to write. So 3 minus 2 into minus 1 plus 2. And here it is minus 4. So 3 plus 2, 5. So 5 minus 4 is 1. So we got determinant of a equal to 1. So determinant of a not equal to 0 means inverse will exist. So which means a inverse will exist. A inverse will exist. So now we have to find a inverse is nothing but 1 by determinant of a, which is 1 by 1 into adjoint of a. From here we can say a inverse will be equal to adjoint of a. You can say this property also if determinant of a is equal to 1. So now we have a inverse is nothing but just it is equal to adjoint of a. So now we will see the shortcut to solve the shortcut to find the adjoint of a. Suppose if we have matrix A equal to A, B, C, D, E, F, G, H, I. So we have to find the adjoint of A. So adjoint of A directly we can find without finding minor cofactor. So what I will do here is I have to take this middle element. So E. So in this order I have to take the elements, but while writing I have to write this in row form, because anyway we have to take the transpose of cofactor. So only we are changing the column to row. So E, H, B, then E again. So whatever we started here we will end with E. So we started with E, we will end with E. So next I have to select this F. So next F, I, C, F. So after this we had this one D. So D, G, A, D. So if we see here, this and this is same, and the first row, first column is equal to the last column, and the first row should be equal to the last row, which means again I have to write this E, H, B, E. So now directly I can write the adjoint of A. So adjoint of A is nothing but, so first we had to take the determinant of this. Determinant of this. So this we have to write here, E, H, F, I. Next we have to include this Hi again. So this determinant we have to write here, H, B, I, C. Next we have to include this BC. So this determinant we have to write here. So it will be B, E, C, F. So like this we have to proceed. Now the next thing here, I have to include this also. Fi also I have to include. So it will be equal to F, I, D, G. Next it will be I, C, G, A. This is 2 cross 2 determinant. And this is C, F, A, D. And again I have to include this. So D, G, E, H. Then again this GH I have to include. So G, H, A, B. Again I have to include this column A, B, D, A. So this will be the adjoint of A. So now in this matrix we have 1, 2, minus 2. I'll just copy that. A equal to 1, 2, minus 2, minus 1, 3, 0, minus 1, 3, 0. Next 0, minus 2, 1, 0, minus 2, 1. So what we have to do here is I have to select this 3. So 3, minus 2, 2, 2, 3. Next 0, 1, minus 2, 0. Then minus 1, 0, 1, minus 1. Next first row I have to just copy again. So 3, minus 2, 2, 3. So now directly we can find the adjoint of A. So adjoint of A will be equal to this determinant 3 minus of 0. 0 into minus 2 is 0 only. So it will be just 3. Next this determinant minus 2 into 2. So it is 4. So 4 minus 2. Next this determinant 2 into 0 is 0. So 0 minus of 3 2s is minus 6. So 0 minus of minus 6. Next this determinant we have to find. So 0 minus of minus 1. Next this determinant. So 1 minus 0. Next this determinant. So minus 2 into minus 1 is 2, minus 0. Next this determinant. So minus 1 into minus 2 is just 2. So 2 minus 0. Next this determinant. So 0 into 2 is 0. 0 minus of minus 2. Next this determinant. So 3 minus of minus 2. So now after calculating this, adjoint of A will be equal to 3. 4 minus 2 is 2. 0 minus of minus 6. 0 plus 6. So it is just 6. Minus of minus 1 plus 1. And here also 1. And here we have 2. So here also 2. So minus of minus 2 is again 2. So 3 plus 2. So it is 5. So this is adjoint of A, and A inverse is also the same thing, because we just found determinant of A equal to 1. So now what we have to do here is we have to find AB the whole inverse. So we know the property AB the whole inverse is B inverse into A inverse. So B inverse into A inverse we have to find. So first I will take B inverse from the question. So from the question it is 3 minus 1 1, 3 minus 1 1, minus 15 6, minus 5 5, minus 2 2, 5 minus 2 2. Next we have to take A inverse. So this is A inverse. I'll just copy and paste here. So this we have to multiply now. So how to multiply first row with first column? So first row with first column is 3 3s are, it is 9, minus 1, next plus 2. So next first row with second column this one. So now if we multiply this, 3 into 2 it is 6, minus 1, 1 into 2 plus 2. Next first row with third column, this one. So it will be equal to 3 6 are 18, minus 1 into 2, so minus 2 plus 5. And next second row, we have to come to the second row now. So now second row we have to fix. Second row first column, so minus 15 into 3. So 15 into 3 is 45. So minus 45 plus 6, minus 5 into 2, so it is minus 10. Next minus 15 into 2, so it is minus 30. Second row, second column. See here, this is the place A11, A12, A13, A21, A22, A23. So A31, A32, A33. So if we have to find A22, suppose, which means we have to take second row from first matrix and second column from second matrix. So if we have to find Aij, we have to take ith row from first matrix, suppose AB, then I take ith row from matrix A and jth column from matrix B. So here it is minus 30 plus this 6 into 1 plus 6. Next minus 10. So second row, second column, minus 5 into 2 is minus 30, plus 6 and minus 10. So second row, third column, so minus 5 into minus 15 into 6. So minus 15 into 6 is 90. So it is minus 90. 6 2s are 12, minus 25. And now third row, first column. So 5 3s are 15, minus 2 plus 4. 5 3s are 15, minus 2 plus 4. 5 2s are 10, minus 2 plus 4. So here 5 6 are 30, minus 4 plus 5 2s are 10. So this will be the answer. Now we have to just simplify this. I'll write the final answer here. B inverse into A inverse. So B inverse into A inverse. This we have to simplify. So B inverse into A inverse is nothing but, so 9 minus 1 plus 2. So it will be equal to 10. 6 minus 1, 5. So 5 plus 2, it is 7. So 18 minus 2 plus 5. So it will be equal to 21. Next minus 45 plus 6. So minus 45 minus 10 is minus 55. So minus 55 plus 6 is minus 49. So next minus 30. Minus 30 minus 10 is minus 40. So minus 40 plus 6. So it will be minus 34. Next minus 90 we have. So minus 90 minus 25. So it will be equal to minus 115 plus 12. So it will be equal to minus 103. And 15 plus 4, minus 2 plus 4, it is 2. So 15 plus 2, it is 17. So 10 plus 4, it is 14. So 14 minus 2, it is 12. 30 plus 10, 40. So 40 minus 4, it is 36. So this will be the final answer for this AB the whole inverse. Now we have done this question number 9. So now we can start the question number 10. So we have to solve the following system of equation by matrix method. Now suppose if I have one equation a1x plus b1y equal to c1, a2x plus b2y equal to c2. So now what I'm writing here is, going to write here is, in the first column I'm going to write the coefficient of x. If I'm writing the coefficient of x in the first column, I have to write x in the first row here. And in the second column I'm going to write the coefficient of y, which means in the second row I have to write y. So what is the coefficient of x? a1, a2, and here it is b1, b2 equal to c1, c2. Now whatever we have in this, the two simultaneous equation, this can be written like this. If we see here, if I multiply this first row first column, I'll get a1x plus b1y, and second row first column a2x plus b2y, and here I have equal to c1, c2. If two matrices are equal, then their corresponding elements is equal, which means a1x plus b1y equal to c1, a2x plus b2y equal to c2. So which means this can be written like this. Same thing here, if we have two variables and two equation, we will get some 2 cross 2 matrix. So if we have 3 variables and 3 equation, then we will get 3 cross 3 matrix. Here we will get 3 cross 3 matrix since x, y, z, 3 variables we have, as well as we have 3 equations. So here if we see this, we call this as matrix A. We call this as matrix A, and this is matrix x equal to B. So we have Ax equal to B. So Ax equal to B means we can pre-multiply by A inverse on both sides. So this is not, AB is not equal to BA. In matrix, AB is not equal to BA. So Ax equal to B, pre-multiplying by A inverse on both sides. So A inverse Ax equal to A inverse B. So this I cannot write like this BA inverse, because matrix multiplication is not commutative. So we have to pre-multiply by A inverse on both sides. Now since matrix multiplication is associative, A inverse into A is identity matrix. So identity matrix into any matrix, identity matrix into x will be x itself. So x will be equal to A inverse B. So x only we have to find. To find this value of x, we have to find A inverse first. Then we have to multiply by matrix B. So whatever answer we are getting, it will be in this form C1, C2. Or if it is 3 cross 3, it will be C1, C2, C3. So we will get this matrix. So it is very easy to find the solution of x, y and z here using the matrix multiplication method. So now x plus 2y. So this I have to write in this form. First column I am writing the coefficient of x, which means here I have to x. Suppose if I write in first column, if I write coefficient of y, in first row I have to write y. So like this we have to do. So here I will go in order itself. So x coefficient, y coefficient, z coefficient, which means here x I have to write, y, z. So what is the coefficient of x? We have 1, and here coefficient of y, this is equation 1, 2, 3, and here it is 2, minus 1, 1. Suppose if it is given minus z plus 1, minus z plus y. So in this case minus 1 will come here and plus 1 will come here. So minus 1 plus 1, and here it is 3, 2, minus 2 equal to what we have, 6, 2, 3. Okay. Now from here what we can do here is, this is matrix A, and this is matrix X, and this is matrix B. So X matrix only we have to find. So X will be equal to A inverse B, which means for this matrix A we have to find A inverse. So before finding A inverse, first I will check what is the value of determinant of A. So determinant of A will be equal to 1 into minus 1 into minus 2, it is 2, minus 1 into 2 is 2. So minus 2 into, I am expanding along row 1, delete the row in which 2 is present and the column in which 2 is present. So it will be 2 into minus 2, minus 4, minus 3. So plus 3. So now delete the row in which 3 is present. Delete the row in which 3 is present and the column in which 3 is present. So it will be 3 into 2 2s are 4, minus of minus 3. You can write minus first, minus of minus 3. So now it will be equal to 2 minus 2 is 0. So minus 2 into 4 minus 3, which is minus 7. And this is 4 plus 3, 7, 7 3s are 21. So it will be minus 2 into minus 7 is plus 14, 14 plus 21. So it will be 35. So determinant of A is not equal to 0, which means A inverse exists. So what is the formula for A inverse? So A inverse is nothing but 1 by determinant of A into adjoint of A. So which means A inverse will be equal to 1 by 35 into adjoint of A. So now we have to find the adjoint of A. So to find the adjoint of A, what we can do here is, I'll just copy this. So this is matrix A we have, and from here we have to take the middle element, which is this one. So minus 1, in this order we have to go. So minus 1, 2, 2, minus 1. Then the next number is 1, minus 2, 3, 1. Next it is 2, 3, 1, 2. Again we have to come to the minus 1, 2, 2, minus 1. Next, now adjoint of A is nothing but determinant we have to find. So this determinant of this, so minus 1 into minus 2, which is just 2, minus 1 into 2, so which is 2. After this, determinant of this one, 2 3s are 6, 6 minus of minus 4. Next, determinant of this, so 2 minus of minus 3. So next, this determinant, so 3 minus of minus 4. Next, this determinant, so it will be minus 2 minus 3 3s are 9. Next, this determinant, 3 2s are 6, 6 minus 1. So after this, determinant of this one, 2 2s are 4 minus of minus 3. Next, determinant of this, 3 2s are 6, 6 minus 2. At last, determinant of this, 1 into minus 1 minus 4. So now this determinant value will be 2 minus 2, it will be 0. 6 plus 4, so 6 plus 4 is 10. 2 plus 3, it will be 5. 3 plus 4, minus of minus is plus, 3 plus 4 is 7. Minus 2 minus 9 is minus 11. 6 minus 1 is 5. 4 plus 3, it is 7. 6 minus 2, it is 4. Minus 1 minus 4 is minus 5. So this is our adjoint of A. So A inverse is nothing but 1 by determinant of A. So A inverse is 1 by determinant of A we got here is 35 into adjoint of A. This matrix, just we have to copy and paste here. So this will be A inverse. Now final answer is my X. X matrix only we have to find. Matrix X is nothing but A inverse into B. So X is nothing but A inverse into matrix B. So A inverse, we can keep the constant out itself. So 1 by 35 into again this matrix. Into matrix B. So matrix B we have here is 6 2 3. 6 2 3. So now we have to multiply first row with first column. From this we have to take first row, and from here we have to take first column. So which means here it is 1 by 35 already we have. So matrix X is equal to 1 by 35 into 0 into 6 0. 10 into 2 plus 20. 5 3s are 15. First row, second column we don't have, which means we have to close this. Second row, first column, 6 7s are 42 minus 11 2s are 22 plus 5 3s are 15. So 6 7s are 6 sevens are, again it is 42, plus 4 twos are, it is 8, so again then minus 15. So now we have to calculate this. So matrix X is equal to 1 by 35 into 20 plus 15 is 35, 42 minus 22, it is again 20, so 20 plus 15 again it is 35, 42 plus 8 it will be 50, so 50 minus 15 again it is 35. So which means if I multiply this 1 by 35 inside, so X will be equal to 1 1 1. So what is matrix X actually? So matrix X is nothing but X Y Z, X Y Z. So which means corresponding elements will be same if two matrices are equal. So from here I can say X will be equal to 1, Y is equal to 1, and Z is equal to 1. So 1 comma 1 comma 1 will satisfy this first equation, second equation, third equation. So how we have to check whether our answer is correct or not? So just substitute 1 1 1 in all three equations. So 1 plus 2 plus 3, so it should be equal to 6. Yes, 3 plus 3 it is 6. So for the first question it is valid. For the second question, 2 minus 1 plus 1, minus 1 and plus 1 will get cancelled, equal to 2. So for the second equation also it is valid. So 3 plus 2 minus 2 plus 2 minus 2 will get cancelled, so it will be equal to 3. So for the third equation also it is valid. So from this we completed the 10th question. So now we can start the 11th question. So first we have to find the inverse of this matrix A. So matrix A is given as 1 minus 1 2 0 2 minus 3 3 minus 2 4. So before finding A inverse, first we will check what is the value of determinant of A. So determinant of A, it will be equal to 1 into 2 4s are 8, minus 3 into minus 2 is plus 6. Next this sign we have to change, minus of minus 1 is plus 1. Then delete the row in which minus 1 is present, the column in which minus 1 is present. So 0 into 4 0, minus, put bracket, minus 3 into 3 it is minus 9. Next I am taking the element 2. So delete the row in which 2 is present and the column in which 2 is present. So it will be 0 into minus 2 0, minus 3 2s are 6. So the final answer it will be 8 minus 6, it will be equal to 2. Minus of minus 9 is plus 9, 1 into 9 is 9. So 0 minus 6 minus 6, 2 into minus 6 it is minus 12. So now from here 9 plus 2 is 11. So 11 minus 12 is minus 1. So determinant of A is equal to minus 1, which means A inverse exists. So now how to find the A inverse? To find the A inverse we have to find adjoint of A. So A inverse is nothing but 1 by determinant of A into adjoint of A. So how to find the adjoint? We have to take this middle element, so which is 2 we have. So 2. Next minus 2, minus 1, 2 again. Next we have minus 3, 4, 2, minus 3. Next 0, 3, 1, 0, 2, minus 2, minus 1, 2. So after this we have to take the adjoint of A now. Adjoint of A, it will be equal to determinant of this. So it will be 2 4s are 8. 8 minus 3 2s, minus 3 into minus 2 is 6. Next this determinant, so minus 2 into 2, so it will be minus 4, minus of minus 4. Next minus 1 into minus 3, it is just 3, minus 4. So we can just close this. Next this one, minus 3 into 3, it is minus 9, minus 0. So after this I will just 4 into 1, 4, minus 3 2s are 6. Next this one, 0, minus of minus 3. Again here 0, minus 6, minus 3, minus of minus 2, 2, minus 0. So from here we got adjoint of A as 8 minus 6, which is 2, minus 4, this is minus 4 plus 4. So which is, it is 0. 3 minus 4 is minus 1. Here minus 9, and 4 minus 6 is minus 2. Minus of minus 3 is plus 3, and 0 minus 6 is minus 6. Minus 3 plus 2, which is minus 1. So here just 2. So this is my adjoint of A. So after this we have to find A inverse. So A inverse, it will be equal to 1 by determinant of A, which is minus 1. Determinant of A is minus 1. So 2, 0. So just we have to multiply this minus 1. Suppose K times A matrix is this K constant, I have to multiply to each and every element inside the matrix, which means this minus 1 I have to just multiply to each and every element inside this matrix adjoint of A. So it will be equal to minus 2, 0, plus 1. Just we have to change this, and plus if we have, it will be minus. Minus if we have, it will be plus. So it will be minus 2, 0, 1, 9, 2, minus 3, 6, 1, minus 2. So this is our A inverse. So now in this question, after finding the value of A inverse, solve the following system of linear equation: x minus y plus 2z equal to 1. So what we have to do, 3 variables and 3 equations we have. So which means here I will write, in the first column I am going to write the coefficient of x, coefficient of y here in the second column, and in the third column coefficient of z, which means here I have to write x, y, z. So now from here what we have here is 1 minus 1, 2, 1 minus 1, 2. Next, so here x is not there, which means 0x we have. So 0x plus 2. Here in this first column I have to just write coefficient of x. I cannot proceed with 2 here. So if x term is not there, it is understood here the coefficient of x is 0. So 0, 2, minus 3. 0, 2, minus 3. Next, 3 minus 2, 4. 3 minus 2, 4. And it is equal to the constant part whatever we have. So 1, 1, 3. 1, 1, 3. Now if we see here, this is nothing but matrix A. Just now we found the inverse of that matrix. Matrix A, 1 minus 1, 2, 0, 2, minus 3, 3, minus 2, 4. So this is nothing but matrix A. So we just found this is A inverse we have. So this is matrix X equal to B. And we know that X will be equal to A inverse into B. So A inverse we have already, this is A inverse. I'll just copy this. Copy. I will paste here. So this is A inverse. And the next thing here is matrix B we have, which is 1, 1, 3. So now just we have to multiply. So first row with first column. So minus 2 into 1, minus 2. 0 into anything is 0. So plus 3. So next 9 into 1, 9, plus 2, minus 9. Next 6 plus 1, minus 6. So which means the values will be 3 minus 2, it is 1. 9 minus 9, 0. Then just 2. And here 6 minus 6 will get cancelled, it will be just 1. So this is matrix X we got. So matrix X is same as X, Y, Z here. So which means from here after comparing, so if two matrices are equal, corresponding elements will be same. So which means from here I can write x equal to 1 and y equal to 2 and z equal to 1. To check whether our answer is correct or not, so we can just substitute these values in the three simultaneous equations we have. So here in the first, x is 1 we got, and y we got 2, and z we got 1. So just we can substitute in place of x 1, in place of y 2, plus 2 into 1, which is 2. So 2 and minus 2 will get cancelled. So 1 we have in RHS. So the first equation it satisfies. So for the second equation we have 0x, no need to substitute x. 2 times y, 2 2s are 4. So 4 minus 3. So 4 minus 3 is 1. For the second equation also it is true. What about the third equation? So 3 minus 2 2s are 4 plus 4. So 4 minus 4 will get cancelled. So 3. So for third equation also it satisfies. So our answer is correct. Like this we can check whether our answer is correct or not. Now coming to the 12th question. So in this 12th question, we have to find A inverse. Matrix A is given. So matrix A is given. So first we have to find determinant of A. So determinant of A, it will be equal to 2 into, delete the row in which 2 is present and the column in which 2 is present. So 2 into minus 2, minus 4, minus of minus 4. Then I have to change the sign. So plus 3 into, delete the row in which minus 3 is present and the column in which minus 3 is present. So 3 into minus 2, minus 6, minus of minus 4. Then plus 5 into, delete the row in which 5 is present and the column in which 5 is present. So 3 minus 2. So now it will be equal to 2 minus 4, minus of minus 4 is plus 4, plus 3 into minus 6, minus of minus 4 is plus 4, plus 5 into 3 minus 2 is 1. So 4 minus 4, minus 4 plus 4 is 0, minus 6 plus 2 is minus 2 plus 5. So it will be minus 6 plus 5 equal to minus 1. So determinant of A equal to minus 1. Determinant of A is not equal to 0, which means A inverse exists. So how to find A inverse? We have to find adjoint of A, because A inverse is 1 by determinant of A into adjoint of A. So to find this adjoint of A, what we have to do? We have to take this 2, 1, minus 3, 2 again. Next after this we have minus 4, minus 2, 5, minus 4. Next 3, 1, 2, 3. Next first row again I have to copy. So 2, 1, minus 3, 2. So now we will find adjoint of A. So adjoint of A here is adjoint of A equal to, so the determinant of this, so 2 into minus 2, minus 4, minus of minus 4 plus 4. Next after this determinant of this one, so it means 1 into 5, it will be 5, minus 2 into minus 3 is plus 6 only. Next determinant of this, so minus 3 into minus 4, it is 12 minus 10. Next it is minus 4 plus 6. So next here minus 4 minus 5, here 15 plus 8, here 3 minus 2, minus 3 minus 2, so 4 plus 9. So this we have to add now. So minus 4 plus 4 is 0, 5 minus 6 is minus 1, 12 minus 10 is 2, so 6 minus 4 is 2, minus 4 minus 5 we have to add and we have to write the minus sign. So minus 9, so 15 plus 8 it will be 23, 3 minus 2 it will be 1, minus 3 minus 2 is minus 5, and 4 plus 9 will be 13. So this is our adjoint of A. Now we have to find A inverse. A inverse is nothing but 1 by determinant of A. So determinant of A is what? Minus 1. So this minus 1 we have to just change the sign here. So it will be 0, 1, minus 2. Because each and every element we have to multiply with minus 1, which means plus will change to minus and minus will change to plus. So here we will have minus 2, 9, minus 23, and here minus 1, plus 5, and here it will be minus 13. So this is what we got for A inverse. So now after this what we have to find here is using A inverse, which means directly we should not solve this. We have to use this A inverse here to solve this simultaneous equation. So here what we have to do here is 2, 3, 1. I'll write in this form. So 2, 3. So 2, 3, 1. Next we have minus 3, 2, 1, minus 3, 2, 1, and next 5 minus 4 minus 2. So 5 minus 4 minus 2. Next, after this, x, y, z equal to, here in RHS we have 11, 4, minus 9. So 11, 4, minus 9. So after seeing this, if we see here, this 2 minus 3, 5 is there, which means first row of matrix A is in first column, and second row 3, 2, minus 4 of matrix A is in the second column. Second row is in second column, which means this is nothing but A transpose. Whatever we have there, so this is nothing but A transpose. So A transpose into matrix X equal to B, like this we have now. So which means X will be equal to A transpose, whatever we have, the inverse of A transpose into B. So I have written the property here, A transpose property. So A inverse the whole transpose is same as A transpose the whole inverse. So I will write the same property here. So A transpose the whole inverse will be equal to A inverse the transpose. Transpose of A inverse we have to do, and this is A inverse. So A inverse transpose is what? We have to change the row to column and column to row. So 0, minus 2, minus 1, 1, 9, 5, minus 2, minus 23, minus 13. So this is A inverse the whole transpose we have. So just I will shift this here. So now this is same as X equal to A inverse the A transpose of A inverse into matrix B. So now X will be equal to this matrix. I'll just copy this. This the transpose of A inverse into matrix B, so which is 11, 4 and minus 9. I had to just multiply this. This is my matrix X. So here how to multiply first row with first column? So which means 0 into anything, 0 only. Minus 8, minus 1 into minus 9, so it will be plus 9. Here it will be 1 into 11, 11 plus 36, so minus 45, so minus 22. So 4 into 23 is 92, so minus 92. So next 13 into 9, so 13 into 9 is 117, so minus into minus plus, so plus 117. So here it will be equal to 9 minus 8, it will be 1. Next 11 plus 36 minus 45 we have, so it will be equal to minus 31. And here minus 2 minus we have, which means we have to add that, minus 22 plus 22 plus 92, and we have to write the minus sign, so it will be equal to 114. So minus 114 plus 117 we have, so which is equal to just 3. So this actually this is equal to XYZ. So if two matrices are equal, then their corresponding elements are equal, which means I can say X equal to 1, Y equal to minus 31, and Z equal to 3. So we have to check whether our answer is correct or not. Our answer is correct or not. So we got the values of X as X equal to, we got, just see that, 1 minus 31, 3. 1 minus 31, 3. So 1 minus 31, 3. So in the first equation, if I substitute this, so it will be 2 into 1, 2 plus 3 into minus 31, 3 into minus 31 plus 3. So it will be equal to, so if I substitute this, 2 into 1 plus 3 into minus 31 plus 3, so it is equal to minus 88. But here we have only 11, which means some mistake in calculation we have. So this part is correct. 11 plus 36 minus 45. So it is 2, not minus 31. So which means the value of y is 2 here. So 1, 2, 3. So 1, 2, 3 only. X is 1 and y is 2. So now we will substitute. So like this we can check whether our answer is correct or not. So 2 plus 3 2s are 6 plus 3. So 6 plus 2 8, 8 plus 3 11. So for first equation it is correct. What about the second equation? Minus 3 plus 2 2s are 4 plus 3. So it is equal to 4. Yes, for the second equation also it is correct. So 5 minus 4 2s are 8 minus 2 3s are 6. So 5 minus 14. So minus 5 minus 14 is minus 9. For the third equation also it is correct. So which means our answer is correct. Like this we can check whether our answer is correct or not. So now we can do the 13th question. So in this matrix A is given, then find A inverse. So first we will find A inverse. Determinant of A first we have to check. It should not be equal to 0. So determinant of A equal to 3 into minus 7, it is minus 21. Minus 5 2s are 10. So determinant of A we got minus 31. So determinant of A is not equal to 0, which means A inverse exists. So we have to find A inverse. So A inverse is nothing but 1 by determinant of A into adjoint of A. So here it will be equal to 1 by determinant of A is minus 31. Finding adjoint of A for 2 cross 2 matrix is very easy. Suppose if matrix A is ABCD, adjoint of A is nothing but just we have to shift the diagonal elements. So D A. So just we have to shift the diagonal elements, and for the non-diagonal elements we have to just change the sign. So here it will be minus B and this will be minus C. So finding adjoint of A for 2 cross 2 matrix is very easy. So here it will be just we have to shift the diagonal, which means minus 7 will come here and 3 will come here. And for non-diagonal elements we have to just change the sign. So here it will be minus 2 and this will be minus 5, and this is nothing but A inverse we have. So we got A inverse equal to minus 1 by 31, minus 7, minus 2, minus 5, 3. So if we want we can just multiply this minus sign inside. So minus will become plus and plus will become minus. So it will be like this. So this is the A inverse we got. This is A inverse. So now we have to solve this system of equation 3x plus 5y equal to 11. So this can be written like this. In the first column I am writing the coefficient of x. So which is 3 will come here and 2 will come here, and here it will be 5 minus 7 into, so in the first column coefficient of x is there, which means in the first row we have to write x, y here, and it is equal to 11 minus 3. So now if we see here this 3 5 2 minus 7, so in first row we have 3 2 matrix A if you see, but here 3 2 is in the first column. In the second row we have 5 and minus 7. In the second column we have 5 and minus 7 here. So which means this matrix is A transpose. So A transpose into matrix X equal to, so this I will take matrix B. So which means X will be equal to A transpose, the inverse of A transpose into matrix B. And we know the property A transpose, the inverse of A transpose is same as A inverse transpose. So which means I can write this as X equal to A inverse transpose into B. So A inverse just now we found, so it is 1 by 31, 1 by 31. I had to take the transpose of this, which means 7 will come here and 5 will come here, 2 minus 3 into matrix B, and matrix B is 11 minus 3. So now I have to multiply this. So X will be equal to, so 1 by 31 into 7 into 11 77, 5 3s are 15 minus 15, 2 into 11 22, minus 3 into minus 3, so it will be plus 9, so 1 by 31 2, so 77 minus 15 is 62, 22 plus 9, so it will be equal to 31. So now I can just multiply this 31 inside, so x will be equal to 62 divided by 31, so it will be equal to 2, and this will be 1. And this matrix X is nothing but x comma y. So here it will be x comma y. So corresponding elements we have to equate, which means x will be equal to 2 from this and y will be equal to 1. So after getting these values, we have to check whether our answer is correct or not by substituting the values in the equation. So x is 1, x is 2 and y is 1. So 3 into 2 plus 5. So 3 2s are 6, 6 plus 5 it is equal to 11. Yes. And for the second one, so 2 into 2 4 minus 7. So 4 minus 7 it is minus 3. Yes, it is correct. So now we can go to the 14th question. So here in this 14th question, matrix A is given and matrix B is given. So we have to find AB, A into B. This matrix we have to find. So A matrix I will just copy minus 3, minus 2, minus 4, 2, 1, 2, and here again 2, 1, 3 into matrix B, so which is 1, 2, 0. Next minus 2, minus 1, minus 2. So 0, minus 1, plus 1. So this we have to multiply. So first row with first column. So first row with first column, so which is equal to minus 3 into this one, first row with first column. So here it will be equal to minus 3 into 1 minus 3, minus 2 into minus 2, so it will be plus 4, minus 4 into 0 is 0 only. Next first row with second column, so minus 3 into 2 minus 6, minus 2 into minus 1 plus 2, minus 4 into minus 1 plus 4. So next first row with third column, so 0, minus 2 into minus 2 plus 4, so it will be minus 4 here. So after this 2 into 1 2, minus 2 0, then 2 into 2 4, so 4 minus 1 and minus 2. So after this 2 into 0 0, plus 1 into minus 2, so minus 2 plus 2. So 2 into 1 2 minus 2, then we have 0 only. So 2 into 2 4 minus 1 4, 2 into 2 4 minus 1 minus 3. So last 2 into 0 0, plus 1 into minus 2 plus 3. So this we got 4 minus 3 is 1. So here minus 6 plus 6 it is 0, and 4 minus 4 0, 2 minus 2 0, 4 minus 3 which is 1, and 0 minus 2 plus 2 0, here also 0. So 4 minus 4 0 here, 3 minus 2 it is 1 here. So which means this is nothing but identity matrix we got, I3. So here we got matrix A B equal to I. Suppose if we have like this, B is the inverse of A, B is the inverse of A, and we can say this also, A is the inverse of B, A is the inverse of B. So which means what I can say here is this B is equal to A inverse and this A is equal to B inverse. So like this we can say. So both are correct. Now next thing what we have to find here is, and use it, we have to use this AB whatever we have solved, use it to solve the system of equation x minus 2y equal to 3, 2x minus y minus z equal to 2, minus 2y plus z equal to 3. So just I will copy that. So x minus 2y equal to 3, first equation we have. So x minus 2y, if it is equal to 3, I can write in this form x minus 2y plus 0z equal to 3. The coefficient of z is 0 here in the first equation. So 2x minus y minus z equal to 2. So 2x minus y minus z is equal to 2, second equation. Next, x term is not there, so 0x minus 2y plus z, 0x minus 2y plus z equal to 3. So we have 3 equations like this. So how to write this in matrix form? So we can write in this form. So here I am writing the coefficient of x, and here I am writing the coefficient of y, coefficient of z. So in the first column, if I write coefficient of x, I have to write x in the first row, here y in the second row, z in the third row. So x coefficient is 1, and here it is 2, and here it is 0. So here it is, for the y coefficient is minus 2, minus 1 and minus 2, and z coefficient is 0, and here it is minus 1 and plus 1. So it will be equal to 3, 2, 3. So now we have to compare which matrix we got, whether we got matrix A or matrix B. So after comparing 1 minus 2 0, minus 2 minus 1 minus 2, minus 2 minus 1, minus 2 minus 1, minus 2 0, minus 1 1. See, after seeing this, we can compare the matrix B. So I will just copy this and I will paste here. This is matrix B we have, matrix B. But same matrix we don't have here. First column of this is in first row, second column of this is in second row, and third column of this is in third row, which means whatever we have here, this is not matrix B, this is B transpose. So B transpose into X, matrix X equal to, so this I will take some matrix C. You can take matrix C as 3 to 3 equal to matrix C. So now X will be equal to, I have to take B transpose, the inverse of B transpose, pre-multiplying by inverse of B transpose. So it will be equal to B transpose inverse into B transpose, it will be equal to identity matrix. So X will be equal to the inverse of B transpose into matrix C. And we know the property, so B transpose, the inverse of B transpose is same as, after finding B inverse, we can take the transpose of that. So which means from here, B inverse we have already. B inverse is nothing but the matrix A. So what is the matrix A we have? So this I will just copy. This is matrix A. This is matrix A. And B transpose is same as B inverse, the whole transpose into matrix C. B inverse is nothing but the matrix A. So A transpose into C. So this is X. So X we know, X equal to A transpose we know. So just we have to take the transpose of this, minus 3, first row will change to first column, minus 3, minus 2, minus 4, second row will change to second column, so 2, 1, 2, third row will change to third column, so 2, 1, 3. So this entire thing is A transpose. And into matrix C. So matrix C is what? 3, 2, 3. 3, 2, 3. So this just we have to multiply. So then X will be equal to, so this if we start multiplying, so it will be equal to minus 3 into 3, it is minus 9, plus 4, plus 3 2s are 6, next minus 2 into 3, minus 6, plus 2, plus 3, so minus 12, plus 4, plus 9. So it will be equal to 6 plus 4 10, so 10 minus 9 it will be equal to 1, 2 plus 3 5, 5 minus 6 it will be equal to minus 1, minus 12 plus 4, so it will be equal to minus 8, so minus 8 plus 9 it will be equal to 1. So this is nothing but XYZ, matrix XYZ. So from here, after comparing, what we can do here is X equal to 1 I can write, and Y equal to minus 1 I can write, and Z equal to 1 I can write. So after this we have to check whether our answer is correct or not. So after coming here, so we got the values of x as 1, x equal to 1, so y equal to minus 1 and z equal to 1. 1 minus 1 and 1. Yes. So in the first equation I will just substitute this. So 1 minus 2 into minus 1. So 1 plus 2, it is equal to 3. First equation. So first equation is satisfied. And 2 into 1 minus of minus 1 plus 1 minus 1. So 2 plus 1 3, 3 minus 1 is 2. So yes, second equation also it's satisfied. And third equation minus 2 into y, so which is minus 1 plus z, which is 1. So 2 plus 1, it is equal to 3. So third equation also it's satisfied, which means our answer is correct. So from this we are completed with this chapter determinants. So in next class we can start integration, application of integrals. We can start in the next class, question number 15th.